All right, we are in Algebra 1, Lesson 16-4. Today's date is Wednesday, April 24th, 2019. We're talking about vertex form today. Thank you so much. Jessica's notes are hidden away now. Everyone say hi, Jessica.
Hi, Rata.
Yeah, we miss you, Jessica. All right, so factored form versus vertex form. So we've studied this guy already. Factored form, we have studied, it looks like this. It's 3/8 times these things that are being multiplied together. That looked like our homework last night. This is really, really easy to find what? So here are your possible choices. It's really easy to find the y-intercepts. It's really easy to find the x-intercepts. It's really easy to find the vertex. It's really easy to find, those are the basic three. One of those three. Take a guess.
Vertex?
If it's not vertex form, it's probably not going to be vertex, but good guess. So Gunnar, you get the XP for guessing.
Easy XP.
Easy XP. Anyone else want to take a guess, Jose? There it is, x-intercepts.
Oh, I helped him with that. I was saying it repetitively. Nope.
So again, there are multiple words for x-intercepts. They are all up there. Technically, if it's a function, what is it called? It's not called x-intercepts. That's only on the graph. What is it called? Look up there. What is it called? Functions have zeros. Write it down. So yes, I agree that x-intercepts are the general idea, but more specifically, I should be writing zeros because this is a function. All right. But if I'm in vertex form, what is it really easy to find? Oh man, it's called vertex form, so Gunnar.
Vertex.
It is easy to find the vertex. There it is. I can't spell.
I didn't get it right last time.
Gunnar was just, he wanted to redeem himself. All right, I definitely have his card. I have Jose's card. Good. All right, so let's talk about vertex form. This is a general case of vertex form. A is just a number, H is a number, K is a number, but X is our variable. So we have like Y equals something with an X in it. So I'm going to label each of these guys. This thing, this A, make sure that you're writing to the left because we need to write in the center and the right. So this A is going to affect how stretched up and down. So do like an arrow that just says stretched up and down, stretch. There's a formal way of saying this. It's called the horizontal, it's the vertical stretch or compression. But just know that this will make it skinny by stretching it out this way or squishing it down this way. It's going to affect what that function looks like. So if I have like 1/3, it's going to be really fat. And if I have 8, it's going to be really skinny. So it's going to affect how it looks in terms of its shape.
So if it's 8.
So you want to be thinking of this also in terms of the shape. It's not super important to figure out what A does aside from whether or not if it's positive or negative. We'll talk about that down here. But for now, just think of it as the shape. All right, H. This guy right here. We'll do H in green. H. This is going to move left or right. The technical word that we use, and I'm going to start using this after today, is called translate. If I am moving to the left or moving to the right, I am translating. Although you could say move, that's the basic language. I'm technically translating to the left and translating to the right. We're okay with move, translate? Okay. And then finally, we'll do this one in red, I guess. I don't like red. Let's do black. K. This thing is also move, but instead of moving left and right, it's going to be moving up and down. So again, if you want to be very formal, you would say this is the translation up and down, or the vertical translation. This green one would have been the horizontal translation. I don't want to confuse you with the terms yet. I just want you to get the general idea of how these letters affect what's going on with the function. All right, so the key thing is you should be able to find the vertex really easily. So what is the vertex? And I'm just going to give it to us because it's kind of hard. It's going to be negative H. Or I guess it depends. So we'll just say H for now and H comma K. But I want to make a note after you write H comma K. This H is negative. So what this means by me putting this negative here is you need to switch the value of H. So if I gave you X plus 3, that means the actual X coordinate is not plus 3, it's negative 3. You need to switch it. This negative right here means switch the value of h. I'm going to write that as well. Switch the sign of h.
I forgot the I and switch.
Switch. Yeah. All right, so sometimes people put negative h down here. I'm putting negative h in the function. So just remember that this guy is switched. So underline this guy. Remember to change the sign. Change the sign. I'm going to be saying that over and over again. You always need to change the sign of that x value. So write it down. Try to remember that that one is always going to be changing the sign. K is just k. If I put plus 3 on the outside, the y coordinate is positive 3. If I write minus 7, the y coordinate is minus 7. It's really straightforward for the k value. The h one is going to be confusing. Okay, next part. A. If it's positive, if it's negative, how do we say that?
It opens up and opens down.
Write it down.
Ooh.
If it's positive, it opens up. If it's negative, opens down.
Is that kind of 2 questions, technically?
No. All right, so give me a fist of 5. How well are you following the lesson so far?
5.
Those are some really high scores. Let's see if those translate to doing the homework really well too. Okay, so someone aside from Gunnar,
Oh.
quiet raised hand. What do you set equal to 0 to find the y-intercept? Julian. Exactly. Set x equal to 0. And Julian, therefore, if I'm finding the x-intercept, I set what to 0? There it is. Yeah, thank you, Julian. So that should be review. We've talked about that over and over again. That's just coming back to the same thing. So finally, example 1. I need to find all 3 of these things. First, the vertex. Second, the y-intercept. And third, all of the x-intercepts. So there could be a potential of 2 x-intercepts. So that's 4 things. That's a lot of things to find in one problem. Let's see how well we can do that. By the way, the reason that I'm teaching you how to find these 4 things is those 4 things, if you choose any 2 of them, well, not any 2, a vertex and any of these other things, you can graph it. Today is all about graphing. If I can find the vertex and one of these other things, then I'm ready to graph it. But you always need to find the vertex, which is why I'm teaching you the vertex form, because vertex is really easy to find on this one. All right, everyone write down vertex. Let's find that guy. Where does he live? We're gonna find him.
I already know what it is.
Okay, Gunnar knows where he is. Who else knows where the vertex is? It's gonna be something, comma, something. If you know it, write it down now. Something, comma, something. Who knows the vertex? I see Gunnar's hand. I see Sergio's hand. I see only those 2 hands. Where is the vertex? Sergio.
1 and 4.
1 in positive 4 or negative 4? It is. Yep, Sergio has it correct. Sergio correctly switched this value. It was negative 1. He made it a positive 1. And then he saw negative 4 and he just copied that down, negative 4. Yeah, and it's that easy. You just look at the equation and you know what the vertex is. Thank you, Sergio. All right, let's find the y-intercept. You can just say y-int. You can abbreviate here. The y-intercept. Oh, darn. How do I find that guy again? Quiet raised hand, Andres.
Setting x to 0.
Yep, setting x to 0. So this x right here is going to be 0. I'm going to rewrite that out. So g of x. And instead of writing g of x, can we write y? This thing is the same thing as writing y. So I'm going to say y equals 4 times the quantity of, and here I go, I'm plugging in 0 for that x, minus 1 quantity squared minus 4. Instead of writing the g of x, I change it to a y. They're basically the same thing. I'm just kind of cheating by making it easier on us. You're allowed to do that as well. All right. I have a negative 1. 0 minus 1 is negative 1. Quiet raised hand. What is negative 1 squared? Negative 1 times negative 1. Who knows that?
Positive 1.
Cohen. Yes. 1, and then Cohen do 1 times 4. 4 minus 4. There we go. Y equals 0. Thank you, Cohen. These are just a lot of mental math. You do not need to show all the steps. I mean, you can if you really want to. But at this point, it's just doing mental math. 0 minus 1 was negative 1. Negative 1 times negative 1 was a positive 1. positive 1 times 4 is a positive 4. 4 minus 4 was 4. So it just happened to be at y equals 0. All right. So I found vertex. Check. I found y-intercept. Check. I now need to find the x-intercepts. Here we go. I need to conserve my room a little bit because this is going to be a little bit of work. X-intercepts. How do I do this one? Jose. Set the y to 0. And this g of x is really our y, so we'll do that. So following with Jose, 0 is equal to, I'm going to rewrite the rest of this function. 4 times the quantity of x minus 1, all of that thing squared, minus 4. I'm just rewriting the right-hand side, but I changed that y out front to a 0. Yeah, thank you, Jose. Now, what am I going to do? Question, or you know what you're going to do?
I know what.
You know, okay, yeah, go for it.
So you add 4 on both sides.
There it is. We're going to add 4 to both sides. We've come along so far in Algebra 1 that I'm not even going to write plus 4 plus 4. If you think that you're going to forget what you're doing in your notes, then you can write plus 4 on both sides. But what I'm going to do is I'm going to say, okay, we added 4. I now have 4 on the left-hand side, and this 4 went away, and I now have 4 times the quantity of x minus 1 squared. What I did there was I added 4 to both sides. I'm starting to skip steps, but if you want to show those steps, by all means, keep doing that. All right, what do I do next? Only one person knows. Uh-oh. All right, Jose, give it to us.
Divide 4 both sides.
Yes, we're going to divide both sides by 4. That will cancel out this 4, and this 4 will turn into a what, Jose? 1. So I'm going to rewrite that down. Again, I'm skipping steps here because we know what we're doing. We're dividing both sides by 4. 1 is equal to, this 4 is now gone, x minus 1 quantity squared. Ooh, what are we going to do now? What am I going to do now? Again, I'm trying to solve for x, but now this pesky square is getting in the way. How do I undo a square? Only 2 people know how to undo a square. 3, 4. Fernando, go for it.
Square root of both.
Square root both of them, yep. So when we square root both of them, what's going to end up happening is this square root and that square will cancel out. You can cross both of them out if you'd like. I now have x minus 1 by itself, no more squared. On this left-hand side, Fernando, what do I have?
X minus 1.
Oh, so that was
never mind. Just 1.
Just 1. You have half of it, right?
Plus and minus.
Plus or minus. Every single time we do a square root from here on out, always do plus or minus. Because I could have had this thing, this value could have been positive 1, it could have been negative 1. Thank you, Fernando. All right. And finally, last step, easy step. What am I going to do to both sides, Cohen? Add 1 to both sides. So when I add 1 to both sides, I now have just x, and I have 1 added to this plus or minus 1. That plus or minus 1 stay the same. I'm going to also add this 1 to it. Cool. So I now need to find what those 2 values are. So I'm going to come back up here. So I'm going to choose the positive first. So when I choose the positive, and I have to call on someone that has not raised their hand yet, or that someone that still has their card. When I do the positive, 1 plus 1, what am I going to get? Pretty straightforward. Someone that has their card still. So I'm looking at Josie, I'm looking at Jenny, Monse, and Eder. Monse. There it is. X is equal to 2. And then for the next one, I'm going to choose the negative. Thank you, Monse. Again, someone that has not participated yet. When I choose the negative, what am I going to get? Yeah, Josie. -3. Ooh, careful. 1 minus 1.
0.
There it is, yes. X equals 0. So those are our 2 x-intercepts. Just know that these values are on the x-axis, so technically they should be 2, 0, and 0, 0. But if you just want to leave it as x equals 2, x equals 0, and know that those are the values on the x-axis, then I'm fine with that. Thank you, Josie. All right. Whew, that was a lot of work. We found all of those values, the vertex, the y-intercept, and those 2 x-intercepts. But there's a problem. Flip over to the back. Here is the problem. let's try this problem. And this is going to be the general strategy whenever we're going to graph these. So I'm going to find the x-intercepts of this guy. How do I do x-intercepts again? Only one person, 2 people know x-intercepts, 3 people. Fernando again?
Set the y to 0.
Yep, set this thing to 0, this h of x to 0. So 0 is now equal to x squared plus 1. Thank you, Fernando. All right, I'm going to now subtract 1 on both sides. So when I subtract 1, I now have a negative 1. This positive 1 went away, and I have an x squared. And the next step is to do what? Jose knows. Who else knows? Fernando knows. Cohen knows. Andres knows. Cohen, go for it. Square root both sides. And now our x is by itself, and I need to figure out what the square root of negative 1 is. Here's where we get into a problem. Does anyone know what that problem is, Andres?
I don't know what the problem is, but I know what the answer is.
Okay, yeah, go for it.
What?
It's not 1, actually. I'll show you guys why.
Oh, wait. It's negative 1.
Negative 1.
Are you ready for this? Actually, let's do this. I don't like that calculator. I want to use a different calculator. Desmos.com.
/scientific.
There it is.
Negative
Square root of negative 1.
1. Undefined.
You cannot do that. Not until you learn about the shadow realm of mathematics called complex numbers. But yeah, until you hit late Algebra 2 and pre-calculus, we can't do this yet. We are stuck. We are done. You can't do that. What this is saying in our notes is not possible.
So the answer is not possible.
There are no x-intercepts. We were trying to find the zeros or the solutions, and there are none. There are no x-intercepts. How is that possible? Can someone think about a graph where you have a parabola? So think about it over here on the right-hand side. Can anyone think of a graph that has a parabola that doesn't touch the x-axis? If so, draw it now. I'm going to come around and see if you guys are drawing the parabola correctly. So as many of you put on your graphs, you said a parabola like that, or you said a parabola like that. Yes, both of those don't touch the x-axis. So that's what's happening. Whenever you get x is equal to a square root of a negative, you're never, ever, ever allowed to do a square root of a negative so far in Algebra 1. I know it changes later, but this is saying that it doesn't touch the x-axis. Well, then if I'm trying to graph, maybe I don't want to do all the work to find the x-intercepts and then find it out that it's not possible. So to save you guys time, here's our general strategy for graphing in Vertex form. To do this, we're going to, let's fill this in. Sometimes quadratics don't have, what did we not have? Quite raise hand, Josie? There they are. X-intercepts. So we're not going to find them. So don't worry about finding them. We're only going to find these 2 things. One of them is really easy. It's called this form. And the other thing is the only other third thing that we talked about today. Andres?
Vertex.
The vertex is the first thing. Do you know the second thing as well?
Yeah. The y-intercept.
There it is. And there's only going to be one y-intercept. I probably should have just asked that as a question, but oh well. There's only one y-intercept, one vertex. Only find these 2, and you're golden. This is our last example, and we're done with the notes. So, I have this function. I want you to sketch this. There's going to be 2 things you're going to be finding. You're going to find the vertex, and you're going to find the y-intercept. So what I want you to do right now is in your groups, find the vertex, find the y-intercept, and do your best attempt at sketching this parabola, sketching this function. So again, first find the vertex, then find the y-intercept. We've done that already up here. The vertex you can just look at. The y-intercept you have to do a tiny bit of math. Find those 2, graph them on this graph, and then sketch the answer. All right, someone tell me the vertex and why. That's the vertex. Gunnar, go for it.
It's negative 1, 2.
Vertex is negative 1, 2. Why?
Because the plus changes the sign
Okay.
to negative, and then there's 2.
Yep, so you just look at this one, make it negative, put it there. Just take that one, put it there. You don't have to do any math aside from switching this, and there's the vertex. Next, I'm going to find the y-intercept. Let me come back here and give Gunnar his XP before I forget. Oop, that's the calculator. Boom, and boom. Okay, how do I find the y-intercept, Andres?
So the Want me to tell you the answer first or how to solve it?
How to solve it, please.
Okay, so first you gotta do 0 plus 1. Because you set x to 0.
Set x to 0, 0 plus 1 quantity squared plus 2, and then do the mental math.
So it's 1
Okay?
times 3.
So this 1 squared is 1. 1 times 3 is...
3. And
And-
plus 2 is 5.
Okay, so y is equal to 5?
Yeah.
All right, so we're going to graph these two. Thank you, Andres. And then Mr. Sindel is going to take control from here on out. Oops. It's going too slow. I'm getting lag. All right, so from here, I'm going to graph the vertex. -1, comma 2. -1, comma 2. This is the vertex. Everyone should have this point on your graph. And then my y-intercept is 5. I'm going to come up here and make a point on this y-axis where it crosses the y-axis up here. Know that the vertex is the lowest-most point or the uppest or the topmost point. It could be the minimum or the maximum. And know that it's also on the axis of symmetry. There's this axis of symmetry that's going through here, which means if I have a point at 0, 5, I also have a point over here because of the axis of symmetry. And from there, I do a rough sketch of the parabola. The parabola is going to look kind of like this,
That's exactly what I got.
with arrows going up to the top left, up to the top right. There's my sketch of that parabola. Notice that it doesn't touch the x-intercept or the x-axis, which means if I try to find the x-intercepts, I would get the square root of a negative, saying you're not allowed to do that. There are no x-intercepts. All right, obviously with technology, this is super easy. I just need to drag a point for the vertex, drag a point for the y-intercept, and I'm done. Questions? Okay, I don't want to know how well you can follow the lesson. I want to know how well do you think you can find the vertex, y-intercept, and graph this with technology. How to 5? 5 is I'm going to be a master. I know it. This is going to be easy. I see
5.5.
5.5,
Four.
3, 3,
4 and a
4, 4, 4, 4,
5.5.
4, 3.5, 3.5, and 4. Yeah, okay, those are pretty high scores. So go ahead and write a quick summary. The main thing to take away is what two things do I need to find? Vertex and y-intercept. And the second thing is, how do I find those things? So what do I need to find? How do I find them? Nice quick summary. Once you finish the summary, there are 2 homework assignments on Khan. One of them is really, really quick. It's kind of like a warm-up. The other one is more in-depth of doing what we were just doing for example 2.